Good evening, everyone. We're here for the Raspberry Pi Computing Education and Research Seminar. It's December, it's our final one in this series. I'm Jane Waite, and I am really delighted to welcome you all here today. And we're looking at teaching programming both with and without the use of AI. But of course, most of it has been with AI. And we've heard from an incredible group of speakers this year, and we are so grateful that they've been able to come and present. We also want to say thank you to you, all you lovely people who've come and listened from over 47 countries as we've explored this really new and fast-paced topic in computing education research. And your feedback and the discussion is so important. It's what makes these seminars so special, and we want to say a really big thank you to you all. Next year's 2025 seminar series will be focusing on teaching about data science and AI, and there'll be more details will be shared on our website, and there'll be a newsletter out soon, so please stay tuned. So I am so pleased to welcome, I feel like I've been stalking Leo for a year. I kind of got him kind of signed up, not this year, but like the whole year. No, it's like 18 months, 2 years ago. And I'm going, oh, Leo, come. And he's here. Yay! And he's brought on his friend, Daniel, which is even better. So we get two for the price of one. And my goodness, what these two don't know about this topic, we are really finishing on a high. And they're going to be talking from experience. This is not just theory about how to use GenAI when you're teaching introductory programming. And although it is aimed, obviously, at university level, and some of you I know are in schools, they're still learners. You know, these are introductory programming activities, the same as that we are delivering in schools. So it is about us trying to work out what we can learn from this. Leo is a professor of computer science at the UC San Diego, and he's the co-founder of the Computing Education Research Laboratory, which is dedicated to better understanding how students can learn computing and creating instructional environments where a diverse, and that's the important bit, a diverse group of students can succeed. And Daniel is an associate teaching professor at the University of Toronto and has taught intro Python programming to thousands of students over the past 15 years. And he's also authored and co-authored textbooks on Python, algorithms, and competitive programming, including a book that is all about using AI. And I think that they'll be talking about that book. In this seminar today, Leo and Daniel will be sharing insights from their work, specifically the design and findings of an intro to programming course that fully integrates GenAI into its learning goals. And I think that's the thing for me. It's about the intention in being intentional that makes a big difference to their course. We'll also hear practical ideas for educators on adopting similar approaches, areas for innovation, and the next steps for the wider community. Right, that's my bit done. So thank you for joining us, and Leo and Dan, over to you.
Thank you, Jane, for that very kind introduction. We've been following those previous Raspberry Pi talks that you were just discussing on GenAI and computer science, and I think we can all agree that things are moving remarkably quickly. Dan and I have been involved in GenAI and learning to program for the past few years. That's included writing books, creating courses, conducting research, and we're excited to share with you what we've learned and our vision for introductory programming in the GenAI era. We really have three goals for today, and those are to convey to you first, that the research is moving really quickly and has started to focus on uncovering how to best help students learn with the aid of an LLM. The second is that learning to write software with an LLM requires teaching students a different mix of skills than we've taught in the past. And third, our CS1 LLM pilot that we've been running at UC San Diego has some encouraging findings with regard to student perceptions and their ability to create large software projects. Over the course of today's talk, we'll be talking generally about how students learn to program with LLMs and at times specifically about CS1 in higher education. But just as Jane pointed out, we believe the lessons that we're learning in higher education likely apply, at least in part, to high school students learning to program as well. Our plan is to go over the research, then our vision for the new course, and then our initial findings. I'll turn this over to Dan to kick off the research.
Thanks, Leo. Hey, everybody. So as Leo mentioned, the research is moving super quickly. Honestly, probably like 10, 20 papers have come out since Leo and I started talking. It's really difficult / impossible to keep up with everything that's going on. So what we're going to do is we're going to take a super high level view, and we're going to break the research into two major overlapping generations of GenAI research. The first generation of GenAI papers showed that GenAI solves our intro CS assignments. So this paper is from 2023, and it showed that LLMs were already doing quite well. And that was 2 years ago. It's like, so 2 years ago in LLM years is like an eternity, right? So LLMs are probably at this point even better than they were before. We've also seen that LLMs can solve our exams. So this figure has student scores. Those are the dots on 2 exams. And the blue dot is Codex. Codex was an early LLM. And by early, I mean like 2022. It did pretty well, but it wasn't the best. But after GPT-4 came out, that's the red dot in the figure, it is one of the top students in the class. The reason I'm mentioning this is that LLMs force us to change our assessment practices. Take-home assignments, the ones where you give students precise instructions on what to code, those were really common before. But now we need to move past those, or we risk students disengaging and just like sending the whole thing to the LLM and getting it solved for them. And then online exams are going to suffer the same fate, right? We probably couldn't trust them before, honestly, but now we really can't trust those exams. I'll say a bit more about this later, but we've learned from our surveys of instructors that many are moving to new assessment practices as a result of GenAI. The second generation of GenAI papers, and this is what's happening now, this takes as a given that students are going to be using AI. These papers focus on building tools and otherwise helping students most effectively use GenAI. So for example, we've learned that LLMs are quite good as tutors. So there are tools like Code Help and Code Aid, for example. They have guardrails, and they're meant to help students make progress, but without completely giving away the answer. And these LLMs are typically instructed to be positive and encouraging to students as well. Students note that they like that these tools are always available to them. They can help them fix bugs. They can ask questions without embarrassment or judgment. And they're able to interact with the tools in their native language. These traits are particularly valuable, actually, when you compare them to the behaviors of human tutors in large classes. So this comes out of Leo's lab at UCSD, some research on tutors. And what they found was that sometimes tutors simply give away the answer. And occasionally they can also be discouraging to students. We think actually that the future is going to be a combination of human and LLM tutors. Our sense is that the LLMs are going to be most helpful for well-defined questions, whereas the human tutors can be involved in more deeper global confusions that students might have. The reason we need to focus on helping students effectively use AI is that learning may not be automatic in this context. We're going to highlight 3 papers here. And if you're confused about the findings after we talk about these 3 papers, you're not alone. That seems to be a common concern right now. So the first study is one that we've been referring to a bunch over the past couple of years, and it's one of the encouraging ones. It's a classic experiment. Okay, so we have one group of students, they learn with the LLM, and then we have another group of students that doesn't use the LLM, and then we compare them. These students actually were high school age, so this is directly applicable to those of you teaching in secondary contexts. These students completed tasks in Python. Each task consisted of a code authoring part. Okay, so they wrote some code, and then followed by a code modification part. The LLM group had access to the LLM when they were authoring the code, and the other group didn't. And no one had access to the LLM when they were modifying code. All right, so the key finding is that the LLM group did better on the code authoring. And perhaps that's not surprising. We all, sort of know by now that LLMs are really good at writing code. What is surprising and honestly shocking is that the LLM group also does better when later modifying code without the LLM. So that's a super encouraging finding that really kind of kicked off the motivation for me and Leo a couple of years ago. The second study here found that novices sometimes struggle to communicate with LLMs. They miss important details when they're writing prompts. So for example, they might leave out input and output types, which can cause the LLM trouble. And they try to revise their prompts, typically by changing surface features without changing anything important. Okay. So what these findings tell us is that there are important skills we need to teach novices so they can effectively write prompts. Okay. Effective interaction with GenAI is certainly not guaranteed. The third study is from ICER this year, and it found that students faced different kinds of metacognitive challenges working with LLMs compared to a previous study without LLMs. So the encouraging part of this is that the study found students improved in their ability to solve programming tasks. We love that. So before LLMs, it was 65% success. And then using LLMs, it rocketed all the way up to 95%. So that's fantastic. It's interesting, though, that the interviewers were concerned that some of the students who completed the tasks using LLMs may not have been able to without LLMs. I'm not sure if I agree with that concern. My question is, if students are taught to write code with LLMs, should we really be judging them on their ability to write code without? Anyway, overall, we've had some mixed findings, and there's a lot more research to be done. Okay, so back to trying to help students more effectively use AI. As we've all experienced for ourselves, GenAI is extremely fast, right? It answers your questions extremely quickly. Well, so it turns out it's actually too fast. Students can't easily engage with AI-generated code when it's coming at them a mile a minute. And before students know it, they've accepted a ton of code into their projects, and they may have no idea what any of that code does, and there's no learning happening. So the question is, how can we slow students down a little bit when using GenAI so they engage with the AI-generated code first? One study explored 7 techniques meant to cognitively engage students with AI-generated code. So what it did is they forced students to do something with the code first before they were allowed to use it. For example, some students had to type over the generated code. That was pretty passive. Or they may have had to put code that was scrambled in order before they could use it, or fix bugs that were intentionally introduced, that sort of thing. The ones I just mentioned didn't work all that well. Actually, they kind of annoyed students, to be honest. But what did work well was a technique that they called lead and reveal, where students had to answer a question about what needed to be done next before the next line of code was revealed. And then more broadly, another paper argues that GenAI should be designed to help users reflect on the decisions that are being made. We're super encouraged by this other finding that students themselves are realizing that they may not be learning all that much if the AI just provides the code to them. So we're on the same page with students here, and we need to ensure that our assessments are providing students opportunities to learn. Okay, assessments. So the study here, it's still in the process of being published, but we thought one part was worth sharing. So Leo and I were part of an IDICE 2024 working group. We were all studying how instructors are using, or I guess sometimes not using, LLMs when teaching computing. And the parts I'm sharing here are from a survey of computing educators. So the first thing we found is that instructors are concerned about assessments. As we said earlier, take-home assignments, they're really difficult now to tie to an individual's skills or knowledge. And as a result, instructors are moving toward different types of proctored or oral exams. We also found that 75% of the respondents felt that the skills required to program had changed because of GenAI. We're going to talk all about this in a few minutes. But yet only 30% of instructors had integrated LLMs into their classes. We suspect that this disconnect is partially due to how challenging it is to change your course. And this just means it's even more important to share our materials with each other to help reduce the amount of work it takes to update our courses. At the beginning of the LLM chaos, so like winter 2023, Leo and I decided we would attempt to write a book about how to teach CS1 with LLMs. At that time, there was very little research. We were simply guessing what a CS1 was going to look like, and we were not expecting to have to find the time to work on the book. I sort of, in retrospect, kind of feel like a little guilt. I feel like I tricked Leo into it. I took a lot of psychology courses when I was a student, and I feel like I unleashed so much of that on him. But whatever it was, I somehow tricked him, and we managed to finish. And we're going to talk through our goals of the book and the CS1 LLM course that we built based on the book. In the book, we're reimagining how students or readers should learn to program with the help of an LLM. So first and foremost, we want to teach readers how to use LLMs to help them write programs that are meaningful to them. To do that, we had to identify the key skills when working with an AI assistant. We developed a workflow of writing software with an LLM, and then we identified the skills that are important for each step. Okay, so we're going to talk about our design cycle of writing software with GitHub Copilot. So spoiler alert, this strongly influenced our CS1 LLM course that Leo is going to discuss later in our talk. Okay, so let's say we have a specific programming task that we want to solve. So for now, we're going to assume that this task can reasonably be solved in a single function. So what we would do is we would start by prompting the AI with a description of what we want. And in the book, we guide readers on how to do prompt engineering, right? So writing prompts that give them a good likelihood of getting reasonable code back. Okay, so then Copilot generates the code based on the prompt. And then we read through the code, trying to determine at a high level whether it appears to be a reasonable attempt at a solution. If it's not, we can use the Copilot feature that lets us explore other suggested solutions and select one that may be a better starting point. If after all that we still can't find a plausible solution, we'd go back to the prompt to see if we can better describe the problem. All right, so eventually, hopefully, we find code that we like, and then we can progress to testing the code. And if the code passes our tests, we're finished with this function. If the code doesn't pass all the test cases, we've been there, then we can try to bolster our prompt, or failing that, we can begin a debugging process. In the book and our course, we teach students how to modify code and how to use the VS Code debugger. Okay, so all of that is what you do when working with a single function, but that's not, super realistic. Sometimes we have huge problems to solve, and we cannot just give those to Copilot to solve in a single shot. So what we do is, if we're given a problem that's too large for a single function, we need to find a way to break that down into tasks Copilot can solve. And we do this through problem decomposition. So once we've broken our problem into smaller tasks, we can then start designing each function, and we start from leaf functions on up. And what's cool is problem decomposition actually helps us in the function design cycle. It gives us another tool if we're struggling to get a correct answer for a single function. Okay, so there's obviously a lot involved in many of the steps in this process. So what I would like to do next is talk about what skills students need for each step. So we saw in our workflow on the previous slide that students need to be able to describe the task that they want to solve. We found that Copilot gives better answers when we provide the function's signature ourselves. So students need to know how to name the function effectively and how to describe its parameters and return value. And we've done that here with the find min positive function. Then we need to be able to describe the function's behavior as precisely but briefly as we can. We found that Copilot does better when these are written as docstrings in the function rather than comments. All right, so once students have the suggested code from Copilot, they need to read the code to determine if it's doing what they want. So this is just like what we used to do, right? In a classic, intro CS class, right? They still need to learn how to read and interpret code. That's not going away. They just don't need to know the syntax to the same depth as before because they aren't writing the code themselves. If they determine that the code is not what they want, they need to read even more code, right? They can look at multiple suggestions from Copilot. If none of those are suitable, then they'd have to return to prompting or possibly doing some more problem decomposition. All right, so here Copilot gave us a reasonable answer as the first suggestion. So we would move over to testing, but had it not, so for example, there's some suggestions here on the right, we would have considered those. In VS Code, you can easily ask for these suggestions. So notably, the second suggestion is pretty close to correct, and I can imagine students thinking it is correct. And that's actually okay, though, because the next thing we ask students to do is test the code that they got back from Copilot. Okay, testing. So we all know that it's a very important skill. Students need to be able to write a comprehensive test suite. And this also requires that they be able to read and understand code, right? Because that'll help them improve the coverage of the tests that they write. They'll need to be taught how to perform open and closed box testing, and they'll also need to learn how to write tests for common cases and edge cases. It's also helpful to teach them multiple ways of testing, though we are partial to using doc test in the book and our course. So in the code on the right, we've added a couple of test cases for doc tests that happen to both pass on the Copilot code. All right, so what do you do when you have a bug? So if students can't get any further with prompting and they've decomposed the problem as much as they can, then they'll need to turn to debugging. We teach our students the VS Code debugger. So here we have the VS Code debugger running on some code. Students will need to be taught how to add breakpoints, monitor the state of variables, all the stuff that we typically do when we're debugging. Our code here is running on a test case of 4, -2, and 1. And we're at the second update to min inside the loop. So in the debugger, we can see that min is currently 4 and num is 1. And min is about to be updated to have the right answer of 1. And beyond learning how to debug, a nice side effect here is that this is going to help students follow the flow of variables. And this should help students develop more accurate models of computation. So debugging and using the debugger are skills that many of us probably hope our students have. But I guess embarrassingly for me and Leo and perhaps others, we did not used to explicitly teach this in our intro courses. We spent so much time on syntax that we just kind of kicked away a bunch of the other skills. Now we're able to teach them. As we've said, Copilot is really good at writing code for small functions. So students will need to be able to take a large task and break it into smaller pieces. All right, so the example here is decomposing the task of creating a basic game into smaller functions. And Leo will discuss this later. This is definitely something that students in our intro courses will be able to do, create games. Each of these tasks is then solved with assistance by us following the function design cycle by Copilot. Problem decomposition is challenging for students. It's also one of the most important skills to learn as a programmer. And déjà vu, just like on the previous slide, sadly, we had not been teaching this in our prior courses. We just didn't have time to do it. And now, again, we're able to. Back then, we used to do the decomposition for students, right? That made it easier for us to auto-grade their work. So students weren't doing the decomposing themselves. It did have one positive side effect, I guess, which is it showed students by example what reasonable functions look like. So now we need to do this explicitly. And we do. So we give students lots of tasks that are the correct size for a function and examples of how to recognize when a task is just too big and needs to be broken down into smaller tasks. So part of designing software in Python, and I would personally say part of the fun of using Python is using modules, right? Determining which modules can help us solve our tasks. And people have written, I mean, like there are thousands upon thousands of modules for seemingly every single type of task that you would like to accomplish with Python. What we found, I guess, by chance, working with Python and Copilot, was Copilot Chat, so the chat interface for Copilot, is quite good at helping identify which modules might be helpful for the task that we're trying to solve. So here's an example of asking what library we might want to use for adding a watermark to an image. So Copilot reasonably suggests using Pillow, which is exactly what Leo and I would have suggested our students to use. Beyond just identifying modules, it can also give students pros and cons of using each module, because often Python has, like 10 or something different modules that could be used, and it's confusing which one to use, and it's very convenient for the AI to just give us the pros and cons so we can make a good decision about which module to use. We want to mention this skill specifically because knowing what modules to use for a particular task can help broaden the range of problems solvable by students. In traditional CS1 classes, we often see students struggling with modules that they're not familiar with, and we think it's because we don't teach them explicitly, and it's just so new, right? It's like a very unfamiliar context for students. We are trying to empower students to try new modules, perhaps failing at first. It's not easy stuff, but with the confidence that the AI can help them when they get stuck. Okay, so going back to our goals. So first, we're teaching the skills essential to writing code with an AI assistant. We've gone through those in detail. Second, we teach students how to use the LLM to help them understand code. Okay, so we've talked about the importance of code reading and code tracing, and we're showing students how to use LLMs to explain what the code is doing. Third, we can't talk about using LLMs without also teaching our students about ethical and legal challenges associated with this new technology. Importantly, we note that LLMs can express biases in the dataset, and that can result in things like giving, for example, only European male names if you ask for a test dataset. And lastly, we want to showcase multiple contexts that may be of interest to students. Something like a third of our book is dedicated to things like automating tedious work tasks, or making games, or analyzing data, things that we hope students are going to be encouraged by and excited to learn. Now, I'll pass it over to Leo, who is going to talk all about our new pilot CS1 LLM course.
Thank you, Dan. As you said, I'm going to dive into the pilot course, and I'm going to stress the fact that this is a pilot course. This is still in its infancy. At UCSD, we piloted this course that we refer to as CS1 LLM. With the addition of the LLM, the skills that students need to learn have changed, and so we created a whole new set of learning goals for the course. As in the book, we use GitHub Copilot as our LLM. We also spent time talking about the ethical implications of LLMs, just as Dan mentioned, specifically where they may fail, and that they're apt to represent biases in the data that they were trained on. And you won't be surprised that we stuck with our book goals of having large projects where students picked a topic of interest to them within the domains of data science, image manipulation, or games. Here's our schedule for the course. The course covered Python basics and working with LLMs for the first 4 weeks. And then we spent 2 weeks in each of those 3 programming domains that corresponded to the course projects. For each domain, we revisited key Python concepts while expanding and revising the skills of working with Copilot. In green, I've also highlighted the new skills we taught in the course that correspond to working with GenAI. And you'll also notice that we spent substantially less time on Python basics and syntax, although those basics are revisited multiple times throughout the course in the different domains. Now, many instructors we talk to about teaching a CS1 LLM class are curious about how do you assess students in this environment. And here are the full details of our course structure. Let me just point out a few key elements. The first is, you probably aren't surprised about this, but Dan and I are still teaching using peer instruction. Second, we had the bulk of our grade on proctored assignments. And then the last piece here is that we adopted PrairieLearn as an assessment platform because PrairieLearn allowed us to turn on or off access to Copilot for different assessments, and that was key to our vision for the course. Students had one project for each domain of the course, and I want to say a little bit about these projects. The projects were intentionally open-ended so that students could express their creativity and create something that was meaningful to them. For the first project, they were just instructed to find a data set on Kaggle, ask interesting questions of that data set, decompose the problem into multiple functions, and then work with Copilot to write and test the code. For this project and later projects, we had the students meet with our class tutors to ensure the problems were reasonably scoped, so they weren't too easy or too challenging. The second project asked students to create an image collage after applying multiple image filters, and this project mirrors ones that we've used in our introductory courses based on Mark Grisdell and Barb Erickson's media computation book. And the third project asked students to make their own text-based game, or if they preferred, they could create a game simulator that could simulate the probabilities of winning a game based on particular conditions. You might ask, how do you grade open-ended projects in a large CS1 class? We had that question too. And what we decided we could do is have students turn in code that we could run so we could still see their project. But the bulk of the grading was actually put on their submitted project video. And in this video, we asked them to describe their project, walk through their decisions that they made when they performed problem decomposition, including showing us the UML diagram. And then they had to walk through one function in detail. It took our tutors between 10 to 15 minutes to grade each project, and that was based on a careful rubric, and so it was still a significant effort on this part of my staff. So given the context of the course, let's dive into some initial findings, and these are findings from our IDISI 2024 paper and a recent paper accepted to ACE. So in this course, we had 550 students that were enrolled across two separate sections. It's a pretty large class for a pilot, but that's the size of the classes here that we have at UCSD. I had 6 graduate TAs assigned to the class, and I had 33 undergraduate tutors on the staff to also help support the course. In terms of the course population, you can see the course had slightly more female students than male, and 2/3 of the students were non-majors. We also had a fairly diverse class with roughly 1/3 of our students coming from racial groups that are underrepresented in computing in the United States. Almost half were first-generation students, which meant that their parents did not attend university, and almost half were Pell eligible. Pell grants in the United States are given to low-income students and are generally used as a proxy for low socioeconomic status. And at the bottom, I have a link to the experience report where we publish these findings, and we'll have that link on the last slide as well. In my opinion, the projects were a huge success. We saw students really personalizing their projects by bringing in content that was important to them. I was really pleased to see this, as it meant that students were able to incorporate their major into this course. And I have a couple of examples there. I think if a student were to only take one programming course as an undergraduate, I'd much rather they take this course to become empowered to write software on their own with the aid of an AI assistant, rather than take a classic CS1 class, just because of what we saw them being capable of doing in their projects on their own. There were a number of impressive submissions, so much so that my tutors asked me if they could give bonus points to the really good projects, and I ended up having to cap how many projects each tutor could award bonus points to. And an important point for student perceptions is that they really didn't know what the scope of an assignment is in a classic CS1 class, and so they didn't know that they were solving projects that were much larger and much more complex than the projects we used to assign in our CS1 class. And in hindsight, I wish I'd conveyed that to my students. We asked 3 surveys over the course of the class. You can see that as the term got more busy, we unfortunately had fewer students complete the surveys. We asked a variety of questions on the surveys, and I'm just going to share a few of our findings, but please refer back to the experience report for more details if you're curious. So the first of these findings is at the end of the term, we asked the students about their comfort using GenAI tools to program. And you can see from this Likert question that lighter colors indicate students feeling more comfortable, and darker colors, and like dark purple, is not at all comfortable. We were happy to see that roughly 79% of the students felt either comfortable or strongly comfortable with using GenAI tools to program. We also asked students in our end of term survey about their levels of confidence in performing the following tasks, and we have a legend here at the bottom. In this figure, green shows when students report being confident in performing that task, whereas on the other end of the spectrum, at purple, students are reporting being not confident in being able to perform that task. We found that students felt confident that they could write programs themselves, that they could recognize and understand the code from Copilot, and are gaining a fundamental understanding of programming concepts. They were less confident about being able to identify what they should be able to do without Copilot, and less confident that they could complete the tasks from the course without Copilot. Now, this last question in particular, we don't know if this was a fair question because we expected students to use Copilot for some tasks, like the projects, in the class. And so I wish we'd asked a slightly different question there. In terms of quotes from the student responses, some students felt that Copilot was helpful. They valued how it saved them time coding, and they appreciated the explain code feature. In the second comment, we see a recurring theme from students that they wanted clearer expectations of what tasks they should be able to do with or without Copilot. And in retrospect, this was a key element that we're going to change in the future. And that is that we will make sure that we will mark every question on homeworks as something they should be doing with or without the tool to help guide them in their learning. We were also pleased to see that they valued these programming projects. Here, 74% of the students ranked the projects as either helpful or extremely helpful. Given what I've already said about the projects from our perspective, it was really good to see that students mostly agreed on their value. I have a couple of quotes from those students. So when we asked the students about the projects, we received mostly positive responses like this one that I'll read real quickly. Programming projects were fun, and the amount of freedom that was given added to that. The projects also helped me understand how to put everything that we had learned so far into a project that I could be proud of. The only criticisms received were that students wanted clearer guidelines or wanted more help getting started. So this student says, fun and interesting, but maybe they had a little too much freedom, maybe a few more specific guidelines or suggestions on how to get started. So that wraps up our IDICE 2024 paper, and we want to just give you a quick preview of our just accepted ACE paper that's coming up soon, and we provided a link for that paper at the bottom. Again, these links will be on the last slide. In this paper, we examined student motivations for taking the course and how those student motivations might impact their interest and performance in the course. Specifically, how might their motivations for learning computing change in a course where LLMs are generating content? In particular, we were concerned that students who might want to master all the course content could be discouraged by a tool that does some of the work for them. So fortunately, student achievement goals, which is a form of motivation, have been extensively studied in CS1, thanks really to Dan's research on this area. There are 3 types of achievement goals, as categorized originally in educational psychology. So students may wish to master the content. That's called a mastery goal. They may wish to do better than other students in the course. That's called normative goals. And lastly, they may want to appear to do better than other students in the class, and those are called appearance goals. We measured student beliefs in these goals at the start of the class. And then at the end of the course, we measured their interest in computing. Now, in traditional CS1 courses, it's well established that mastery goals predict interest in computing. And our question really was, will the presence of an LLM change that? And it turns out no. Students with mastery goals still are more interested in learning computing than those without. And we're really encouraged to see that, because we obviously want to encourage students who want to develop a deep understanding of the material to continue in the field. Now, we're short on time, but we had some other interesting findings in this paper that was just accepted. We just put a link to the preprint on this slide, and then it'll be on the last slide of the talk if you want to learn more. Now, we as instructors are all in a really interesting situation right now, where we're trying to understand how best to serve our students, but the research is just starting to come in on how to best do that. And in theory, it'd be great to take 5 years off to really figure out what's the best way to educate students and then come back, but we can't do that. And so for instructors who are interested in integrating LLMs in their courses now, here are the key takeaways from that pilot course that we offered. So first and foremost, we found that LLMs empowered students to be creative, imaginative, and to bring computing to their domains of interest. Students were able to create larger projects than our traditional CS1 course, and we really think that that's the best feature of the course. If you are thinking you might want to integrate LLMs, but only in a limited way, we'd recommend you start with this. Moreover, if you have a population of students at your school who are non-CS majors, who are only going to take one computer science course, let me say again that we really believe a course that teaches them how to program with the aid of an LLM that helps them learn how to build software that's meaningful to them is the one course they should be taking. Our second point is that it may be challenging to ensure that your assessments meet your learning goals. So despite the fact that Dan and I designed this course from the ground up, we still found too often that we were reverting to questions from our classic CS1 classes, and some of those questions weren't as well aligned to our new goals as we would have liked them to be. We'll be improving on that in our next offering, but I just want to caution you all about how easy it is to revert back to our assessments from the past. Our third point is that this was a great deal of work designing this course from the ground up. Many elements of the course didn't change as much as we initially thought, and other elements change more substantially than we initially thought. So for instructors thinking about trying such a course, feel free to start with our materials as we've made them public, and we're happy to support new instructors however we can. Lastly, these are just results from our pilot course. We have more research ongoing, more improvements that we're making. We're still learning from all the great research coming in, and we'll continue to share our materials as we update them. So let me just quickly wrap up the summary of kind of where we're headed right now and what we're doing right now, and then we'll move on to the discussion period. So we're thrilled to be partnering with other educators to integrate GenAI tools into computing, and we are incredibly thankful for these partnerships. The first is working with other instructors to integrate GenAI into CS1. We've had roughly 350 instructors ask for instructor copies of our book, and we're working the next few months to expand the support we can offer to instructors when they adopt our curriculum. We're working with a number of other educators to revise and improve that CS1 course as part of all that, and we'll be updating and releasing our course materials as they come out. And we have 2 ongoing partnerships with teams at Google. The first team is collaborating with us on our research with an emphasis in ensuring that the new course succeeds in serving a diverse population of students. The second team has worked with leading CS educators to develop 5 courses that incorporate GenAI into their teaching. If you might be interested in learning more about their curriculum, you can use the link in that top right corner of our slides to request information on the materials. And I'll also have that link on the next slide as well. As part of my work with Google, I was invited to be part of a panel at Google's recent summit on learning in the AI era, where I got to see the larger educator community, including academics and industry, and I saw how they're all trying to figure out the path forward because of generative AI. And I just want to share that it was clear to me from this event that there are so many unanswered research questions that we need to be answering, and the community needs those answers to really move forward. And it's motivation for us, I think the broader CER community, to really continue this work and get the research done as quickly and as carefully as we can. So with that, I'd like to thank our many collaborators who've helped us on this work, as well as Google and the National Science Foundation in the United States for their funding. We've also provided a number of links here. If you want to request an instructor copy of our second edition, please email me. We also have a link to that second edition of the book as well. If you want to read our papers from this talk, we have those links. If you want a copy of our course materials, the link is there. Or if you want to sign up for more information on that 5-course sequence that Google has produced, working with faculty, you can sign up for information at that link there. So with that, I'd like to move to the next stage, which is our discussion questions. Thank you.
And can everyone just give a huge, huge clap to Leah and Dan? I feel we're in like the minds of these chaps, all these things that they know in their heads. We're very, very fortunate to have had a little bit distilled and shared with us. Please fill out the attendee survey. I can't say more strongly how important it is for you to help us in terms of improving the seminars. As I said before, please post thoughts and comments on X using RPS seminars and also on LinkedIn, etc. So coming up on Tuesday, the 21st of January, that is after what we would call Christmas. People call it the winter holidays and various things. We're going to be hearing from Sushi Grover. And so she is going to be talking to us about teaching with and about AI in K-12. So that's on Tuesday the 21st, Tuesday the 21st of January. That's 2025. And we really look forward to kind of seeing you at our next series. So thank you for coming along. A happy Christmas, happy New Year, happy winter holidays. And thank you to Leah and Dan.